I put this in here. I'll check this out. I think that'll help you with number 9. So this was the next problem that you were having difficulties with, and we want to find all of these 3 lengths and then add them together. Now the first one is pretty straightforward. We've got these two in this nice right triangle, so you can use Pythagorean theorem. Then we're going to jump over to this triangle, and we can find z. After we found the x on this one, we can find z on this one because, look at this. This angle and this angle are the same, and they're both right triangles. So if you get 2 angles of a triangle congruent to 2 angles of another triangle, then those triangles have to be similar. So we can use this information to set up a proportion so that we can find z. After we have that, what I'm going to do is I'm going to look at this last triangle so I can find y. But one thing I neglected to mention, that when I set up this proportion, I can set up a proportion to find this side also. And if I find this side, I can just subtract this from it so that I get this side right here. And you already know this length. It's the same as this. So then again, you can use your Pythagorean theorem to find y. And then once you have x, y, and z, just add them up. Okay, I pulled in a page from the book for this one because we really need a lot of it to answer the questions on this one. Now the first thing I'm going to do is go ahead and mark that, what we have. 118 degrees for that arc. We have CE, which is 25 degrees. I'm going to draw an arrow in there because it's kind of small there. And then we have MY, which is 120 degrees. Now the thing you should notice here is that you have a diagonal. So this is half of your circle, so that will get you this. That way you can get this degree for that chord. And then this is the other half of your circle. So you have these 2 pieces. That'll get you the other arc here. After you have all of your arcs, then you'll be able to use those to find out all the angles, because all of these things are based on your arcs. So we'll be able to do that. RMU is the first one. RMU. So you just have to decide what of these looks like it matches this, where you have a vertex of this angle is on the circle. So that's this one, the inscribed angle. So you're going to look at this formula to find your angle. The next one, MSC is inside. It's formed inside of your circle. It's not at the center, but it's where 2 chords cross. So that one, you're going to look at this one, your intersecting chords, and it gives you a formula for finding an angle when you have intersecting chords. So you can use that one. Then we have MRY, and that has a vertex that's outside of your circle, and that looks like intersecting secants. They run through the circle, they don't run on the outside of it or anything. So you've got a formula for that angle. And then MUR is the one that you need this for, intersecting tangent and radius, because there's your tangent line, that's a radius. So hopefully that will help with those. So here's your last question, and there's a few things that you need to know on this one. Some things that'll help. I'll go ahead and put in the things that we know. We know that AC, which is this diameter here, is 20 inches. And we know that this angle is 120 degrees. It's hard to write on this without touching the iPad with my hand, and that messes things up, so it's a little bit sloppy. But knowing that we have 120 degrees here will tell us something about this arc. So you can look that up. And then, since this is half of your circle, you'll know what this arc is also. Then you've got, since we're looking for BC, we want to know what kind of triangle do we have here. Now this angle goes with this arc, which is half of your circle. So that should tell you something about this inscribed angle. It should tell you what the degrees for it are. And that'll tell you what type of triangle that you have here. Also, knowing this arc will tell you something about this inscribed angle. So you'll have this angle and this angle of your triangle. And you have this length of this side. So there, you could take a look at this or use your trig functions for that. But you might notice you've got some type of nice triangle there that you won't need them, so that you can find BC. But you can always use your trig functions because you'll have your angles and you have one of your sides, so you should be alright. Angle BAC. BAC goes with this arc. It's an inscribed angle for this arc. So you should be able to figure out that one. Now the shaded regions, the way that we're going to find those is we're going to find the area of our circle. Well, we only need half of it, this half of it. And then if we find the area of this triangle, we can subtract that from that. And then you'll have the area of just the shaded regions. Now it's going to take a little bit of calculation, but I think you've got a handle on that. Let me know if there's anything else that I can help you out with.